Hey everyone, Nick Dearbird is here teaching you financial modeling. And today we're going to talk about implementing a basic model in Python. So from previous videos, we've already been talking about this very basic retirement model. We already implemented it in Excel, and now we're going to look at the analogous implementation in Python. So we've got to do a little bit of background on Python before we can just jump right into actually building out the model. From the introduction, we talked about how Python and other programming languages, they basically live in the terminal. They're text-based. You input text, you get text as the output. But of course, we would like to have a little bit more than that. And so there's been a whole ecosystem built around nicer ways to use Python and other programming languages. And so we've got this very nice tool called Jupyter that we can use and will use for the entire class. And Jupyter is a project that brings in all sorts of things along with the code. So you can have nicely formatted text. You can have equations, you can have graphics, you can have, basically anything that you could have on a web page, you can get into a Jupyter notebook and control through your code. Even like interactive stuff like sliders and things that change how your model works. So tons of stuff you can do there. And it's generally just a lot nicer to work with than just working in a terminal. So we're just going to focus 100% on using Jupyter to work with Python in this class. And Jupyter was actually born out of Python. It was a Python project originally. It was actually called IPython Notebook before it was called Jupyter. But the reason they kind of rebranded is they have expanded out into now more than 40 programming languages. This has just become such a popular way to build things that so many people have jumped on this from so many different programming languages. So we're going to keep our focus here. Now, when you're using Jupyter, there's two main versions of Jupyter that you can use, Jupyter Notebook and Jupyter Lab. So Jupyter Notebook is kind of the most basic interface, and Jupyter Lab is taking the Jupyter Notebook and kind of expanding on it. So you can have multiple different notebooks open at once in Lab as different tabs. You can view other kinds of files other than just Jupyter Notebooks. So it has a lot of features. And Jupyter Lab is where the future of Jupyter is. All the new development in Jupyter is going towards Lab and not Notebook. And so we're going to focus on Lab and the class. So I would recommend you use Lab, but if you really don't like Lab, you really want something just a little bit simpler, feel free to use Jupyter Notebook. It's going to be, essentially the same experience. As far as just working within it, it's really not going to be substantially different between Jupyter Notebook and Jupyter Lab. You should, at this point, pause the video and try to get your Jupyter environment set up so you can kind of follow along as I go and implement this model. So we've got some instructions here on how to get Jupyter Lab started. So we can look at that quickly, how we would do that. So the easiest way to do this is to search for Anaconda Navigator. And you see this thing come up here as I search that. You'll see a bit of a delay before the thing actually comes up. And then once it comes up, you can launch Jupyter Lab from that. Now, if you don't have Navigator or you don't want to use that, you can just open a terminal and type Jupyter Lab. That's also going to launch it for you. But this is what Anaconda Navigator looks like. And so from here, you just click launch Jupyter Lab, and it's going to go ahead and launch that for you. So then that will, launch Jupyter like this. So let's go back and look at a couple more Python basics before we actually start using this. But that's basically how you would get Jupyter launched on your system. So, most people are going to be, fairly familiar with Excel at this point. So I think it's helpful to kind of compare and contrast to Excel to understand how we can use Python to do similar things. So in Excel, everything is about the cells, right? You have these different cells, you put the values in the cells, you can make references to the cells. So the basic unit is a cell. For Python, the basic unit is an object. And that's kind of an abstract thing that probably isn't going to have a lot of meaning for you yet. But it's just basically the way of thinking about things in Python. Everything is an object. And we'll see more what that means as the course goes on. So for Excel, you can have numbers in your cells, or you can have characters, letters. That will be called a string. So you can have numbers or strings as your data types for your Excel cells. In Python, we also have numbers, we also have strings, we also have other types. And each object has a type. So it might be an object which has a string type, or it might be something else. So everything is an object, and every object has a type, and that tells you, what kind of data is actually being represented within that object. And then, thinking about referencing our values. So in Excel, we did cell references, right? You put the values, and then you do equals, you click on the cell, equals A2 or whatever, and that will reference the value contained within that cell. So, you have definitely a similar concept in Python, but instead of using cells, we give a name to an object. So you can, whatever object, you can give it a name, and then whenever you use that name, that's going to reference back to that object. So, here's the analogous way of representing these things in Python. So in Excel, you would type 6 in a cell, and you would type ABC in another cell, and then you would reference back to whatever those cell references are to be able to get that value to flow through. Whereas in Python, we just give a name, and then equals, and then whatever our object is. So my number, here the name is my underscore number. And the value, the object which has the type of a number, is 6 here. And then we have my string, another name, equals, here ABC is the string. The object with type string is this ABC on the right hand side. And then going forward, after we've defined these, we can then say my number or my string and be able to get back to 6 or ABC. So that's how everything can flow through. And then thinking about how we do math in Python. So the basic operations are going to be straightforward. 2 + 5 = 7. You can literally just type 2 + 5 and it will give you 7, right? 6 - 2, it's going to give you 4. So all these kind of basic math operations that you would expect just work like you would think. And then beyond that, I mentioned a little bit in the introduction about how Python is a very flexible language with a lot of potential add-on features, right, in the form of these open source packages. So there are all these different, more than 250,000 different packages out there which add little bits of functionality to Python. And so Numpy is one of those packages which add functionality to Python. And with Numpy, we can get all those kind of financial functions that we have out of the box in Excel. So you just bring Numpy into your Python session, and then you can use all these functions. And I told you to download Anaconda in order to get Python. And packaged along with Anaconda, you already have Numpy. Numpy is one of the most popular Python packages in the world. And so it comes out of the box with Anaconda. You just have to bring it into your session. That'll be via an import. We'll look at what that looks like in a moment here. But you just, one line of code to add it into your session, and then you'll be able to use all of these functions. If it was some package where it wasn't already included in Anaconda, then you would have to install it before you could use it. But we'll deal with that a little bit later in the course once we need to go to some things which are outside of Anaconda. And then I just have a note on here about a deprecation warning. So this isn't really anything to worry about. These financial functions in Numpy are actually getting moved to a separate package in the future, Numpy Financial. And so what happens right now, if you use these functions, it will show a warning which just says, hey, we're going to move these functions in the future. It doesn't affect anything for right now. It's just that you're going to see a warning when you use the functions. So just don't worry about that warning. So let's go ahead and look at what this implementation actually looks like. So we're still talking about this simple retirement model where we had a few different inputs. We have the salary, savings rate, investment rate, desired cash. So we would want to first kind of just like we did in Excel, right? We made an input section and then we defined all the inputs. We want to do a similar thing here in our Jupyter model. We want to maintain that same separation of inputs and outputs that we're talking about doing in Excel. So in Jupyter, you can have a section at the top which has all your inputs, and then at the bottom you should have another section which has your main outputs. And then in between you can have other sections for any kind of intermediate calculations. But here, it's a very direct model. So you see these cells here in Jupyter, and you can type code in any one of the cells, and you can run cells individually. And there are also two main types of cells that we'll think about using in this class. We have the code cell and the markdown cell are the two main ways that we'll use it in the class. So the code cell, you're typing code, and then the markdown cell, you're typing this nicely formatted text. So we'll get definitely more into what you can do with this text formatting as we dig more into this stuff. But here, just know if you put this hash, then that can give you a header. So I'm going to say, inputs here, and then when I run that, you can see it comes as this nice header. And I can put some regular text here, and you can see that comes in a regular size there. And to run this, I'm holding Shift and pressing Enter. You can also do this play button that does the same thing. And it's the same thing for these markdown cells as well as the code cells. You run them the same way. So now we have a nice header for our inputs section. Now let's go ahead and type out our various inputs. So first, let's put the salary equals 60,000. Then we have the savings rate. And you'll notice I didn't do savings space rate because variable names cannot have spaces in Python. So the convention is, make them all lowercase, and instead of spaces, you use underscores, and that's what you'll find in pretty much any Python code. And then we have also the investment rate equals 0.05, and the desired cash is going to be 1.5 million. And then you see I hit Shift Enter, and now that it's a code cell, you can see actually this execution count go up each time that I run it. And another thing you'll note is that unlike in Excel, I did not type a percentage sign in here. I typed it in decimal format. You cannot just put a percent like you can in Excel. You can see it actually gives a syntax error if we do that, because that basically means syntax error means Python doesn't understand what you're trying to do. So percent has another special meaning in Python. We're not going to cover that. It's not important for what we're doing, but just know that you can't just put a percent sign and expect it to know that you're talking about a percentage. You have to just put it in decimal is the way that it's going to know. So we have our inputs defined now, and so then we can make the next section determining cache saved. And you'll notice, whenever I'm in the last cell and I run it, it does create another cell. Also, you can, insert cells above and below. Here, it's A and B are able to insert cells above and below, and D twice is able to delete cells. And all of these things are in the menus as well. So you can, if you prefer to just use the menus, you can find all the things in there. But I always just use the hotkeys. So B for below, A for above, DD for delete. And you'll notice also one more thing is that we basically have two different modes here. You can see that switching here, command mode or edit mode. And what I'm doing here is I'm hitting enter to go into edit mode, and I'm hitting escape to go back out into command mode. And when you're in command mode, you can do these A, B, D, D, etc. Whereas when you're in edit mode, then those would be, just typing characters into the cell. So we have our next section, determining cache saved, and now we're going to do our actual calculation of what is the cache saved. So let's call this variable annual cache, and it's going to be salary times the savings rate. And you'll see, one nice feature of Jupyter is we can get auto completion for our variables. If you can't remember what it was called, or you just don't want to go all the way through with typing it, if you're in the middle of typing something, you can hit tab, and that's going to bring up the possibilities. And then as you type, it's going to narrow down the possibilities. And you hit enter to pick the option, or you can up and down to pick whichever option. So here we want the savings rate. And so now we have our calculation. The annual cache is the salary times the savings rate. Okay, let's run it. And now you might say, where is the annual cache? I just calculated it. Where is it, right? And that's one thing which is definitely difficult for people who are used to working in Excel. In Excel, you do your calculation and it shows you the result right away, right? With Python, and this is generally the case with any programming language, it's not going to show you anything unless you tell it to show you something. So the general way to show something in Python is with the print command. So if we print the annual cache, then we can see it is indeed 15,000. But there is a nice shortcut in Jupyter. So in Jupyter, you can just put whatever you want to see as the last thing in the cell, and then it's going to basically print it for you. So it's just, lets you save a little bit of typing. Whatever is on the last line of the cell, it's going to print. So if we just wanted to do our calculation and then see it right away in the same cell, then you can do it like that. Just put whatever variable on the last line, and then you're going to see it right away, and you don't have to do all of that stuff. So we have now the annual cash, and so the last would then be calculating the years to retirement. And definitely take a look at the completed model for this, because it shows how you can be putting more text and a little more formatting in this to really make it a more polished model. But here we're just going kind of quickly. It also explains a little bit more all the various steps that are going on. So we want to calculate the years to retirement, and we talked about how the Numpy library has the NPER, number of periods function, which is going to allow us to do this. But how do we use that? So you don't have access to it immediately in your session. You do have to actually import the package to get access to it. So if we import NumPy, then run that, then all of a sudden we get access to everything which is in NumPy. So then we can do numpy.mper, and you might say, well, how do I actually use this thing? So another feature in Jupyter is you can put a question mark after something and it will tell you about it. So here we can get all the information about this function. We can see that it takes the rate first, then the payment, then the present value, then the future value, which defaults to 0, and then the annuity part, annuity due or not annuity due. Another way you can go about this is, after you type the parentheses here to call this function, if you hold Shift and press Tab, then you're going to see the same thing just come up as a little pop-up here where you can take a look at that. So I use this all the time, Shift Tab, to quickly look at how to use a function. So we're going to then pass in our arguments for this. So our arguments are going to be, first we got to put the rate. So that was the investment rate. And then next we got to put the payment. So the payment is the minus annual cash. And then we've got to put the present value. So the present value is 0. We're not starting with any cash. And then we've got to put the desired cash. And so we do that, and we can see that we get the same result that we did in Excel. Now, this works just fine, but there's a couple things that we want to do to clean this up a little bit. And you can see this warning that I mentioned came up. That's nothing to worry about. Just ignore this warning that comes up. Deprecation warning, you can just ignore that. So there's a couple things we want to do to make this a little bit cleaner. One is there is actually a convention that everyone uses for importing NumPy. If you Google anything about NumPy, you'll see everyone using this same convention, and that's to actually import NumPy as NP, and that basically just renames NumPy to NP, so that then we can do NP dot number of periods, and it does the same thing. So functionally, no difference, but this is just the convention that everybody uses. Then the other thing is that the formatting of this is not very good. We would like to get better formatting of this result. So we can go ahead and save that result to a variable. So we can say years to retirement equals that, right? And so when we look at years to retirement, it is that. But now we want to add some formatting to it. So the way that we can do easy formatting and also, include it in a sentence or anything like that, is with f strings, and we'll dig more into f strings when we go into the Python basics lecture. But basically we can say, Martha has, and then we can drop in our variable years to retirement, and then we can specify the format of that. And then we finish the string. And then we say, that she has 36.7 years to retirement. So this is a lot nicer way to see the result. If someone just sees this at the end, they don't necessarily know what you're talking about, but putting it into a sentence here with, nice number formatting, it becomes very clear what you're talking about. So we'll dig into a lot more of these Python concepts as we go into the basics. This was just a very quick run through on how to build a basic model. And then, there's a useful shortcut up here, kernel, restart kernel and run all cells. So if we say change this to 40,000 and then we restart kernel and run all cells, then we'll see that it updates the years to retirement down here. So that's the easy way that you can just rerun everything in the model in order to be able to get the new result for whatever change in the inputs. So next time we'll come back and we'll look at how we can extend these basic Excel and Python models. So thanks for listening, and I'll see you next time.